Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald en ik zit zoals gebruikelijk met...
Hallo Ronald.
Hallo Jan.
En we hebben echt al een hele berg podcastjes opgenomen. Ja. Ik hoop dat de luisteraars dat wel waarderen. Dat we zulke leuke podcasts...
Ongetwijfeld. We leveren ze natuurlijk kwalitatieve content. Hè? Oh. Dat is natuurlijk...
Maar we zitten nog weer met een gast.
Yeah, we are sitting with a guest from Cast AI. Welcome. For the people who don't know you, can you please introduce yourself to our listeners?
Yes, sure. Hello, nice that I can be here. My name is Kim-Norman Sahm. I'm solution architect from Cast AI.
Okay. And what is your background in the IT? How did you get started?
Oh yeah, I started in IT some years ago. I'm a Linux guy. I'm a Linux operation guy. Originally started, 15, 17 years ago at a German company called Deutsche Telekom. I'm pretty sure you know about them.
Deutsche Telekom.
I'm pain-proofed. And then I grow up in this Linux area, and then I realized, okay, just operation is not enough for me. I need other tasks to do. Started as OpenStack Architect, so I was a lot of heavily involved in this OpenStack ecosystem, which is not existing in this size anymore. So I was looking for another technology. Spent some time with Kubernetes. As Kubernetes was growing up, I was CTO of a cloud consulting company. And so I'm part of this CNCF ecosystem since the last, 7 years, I would say.
Okay.
And it's a challenging environment, but it's also a very cool environment.
Okay, cool.
And what can you tell us about Cast AI?
Cast AI. So Cast AI is a cost optimization platform for Kubernetes. So at the moment, during these times, everybody wants to save money. And it's important to save money. And Cast AI was founded because the cloud builds doesn't really help you to understand what you're paying and for what you're paying. And Cast AI is on the one side cost monitoring, cost visibility, give you insights. What is your Kubernetes spend? Which workloads are generating? Which cost in your Kubernetes cluster? And on the other side, we are an optimization platform. We bring you the automation to right-size your cluster and right-size your workload to reduce this amount of overhead in your cluster. Your applications are not using, but you have to pay for.
I see you thinking.
Yeah, I was thinking. Right-sizing application, how does that work?
Right-sizing application, yeah. So the problem with right-sizing application, in general, with application deployment in Kubernetes.
Yeah.
Kubernetes deployment needs a request.
The request limits.
Yes. So, and how are people defining requests? They have just a rough idea, put it in, it's working, okay, perfect, I will never touch it. And the problem is, we see it that if we compare requests versus real usage, that the requests are mostly 5 times higher than the usage of the application. What does happen? Kubernetes scheduler will exclusively block these resources because they are requested. The applications never consume them, so you pay resources for nothing. And so Cast AI is giving you visibility in this, show you this is the delta, this is the real usage of your application, and we are collecting the usage metrics. We are calculating based on these usage metrics what will be the perfect right-sized request for your application to give the application enough resources to work, but without this big overhead of unused resources.
And the request and limits, in your opinion, are they the same or are they different? Is there a delta between them?
So you have to avoid the situation that you have a delta between requests and limits. Kubernetes scheduler, as well as all the autoscalers, are doing the pod placement based on the requests. So if the Kubernetes schedulers see there are enough resources available so that the request will fit, the Kubernetes scheduler will place the pod there. If your limit are much higher than your request, you will end up in a situation that the node has no resources anymore, the node will crash, your application runs into an out-of-memory kill, something like this. So that's why we say you should avoid the delta between requests and limits to avoid the situation.
And only for memory or also for CPU? Do you set CPU limits?
CPU limits, no. CPU limits is a little bit like religion. A lot of people have different... different
That's where the question is coming from.
Yeah. So we say don't set CPU limits.
If you want to autoscale the application, that's if you use the HPA.
Yeah.
That's set on CPU limits.
So the autoscaling for workloads, depending on in which direction you want to scale. Cast AI's workload autoscaler at the moment is a vertical pod autoscaler. It's our adaptation of an vertical pod autoscaler. So the system is checking how the requests are defined and then define CPU and memory requests vertical. It works together with event-driven autoscaling systems like Hedda. And it's also working together with an HPA if the HPA and the VPA are not relying on the same metrics. So if the HPA and the VPA both relying on CPU, you will end up with a strange situation because then they're fighting against each other.
Okay, you're leveraging the vertical pod autoscaler?
Yeah, so this is our workload optimization platform at the moment is doing vertical autoscaling.
Okay.
In the next quarter, and the next quarter is very close, we are coming with also a horizontal pod autoscaler implementation. So then Cast AI is able to do the vertical and the horizontal pod autoscaling. So because in some situations, it's more efficient to scale up. In some situations, it's more efficient to scale out. And Cast AI will do this decision, what is the best choice in this moment.
If you have an Java application with a heap, and you set the heap, he's smiling already.
I'm smiling because I know what comes next. Yeah. So the Java applications are a problem. Everybody is at the same situation. Java needs this big amount of resources.
Yeah.
And after the start, the CPU goes down. Memory, it's depending on how the Java application is set up. Memory, also in the cloud, memory is cheap, so we can ignore this a little bit. But for the CPU, Java needs a lot of CPU to start up, and then it goes down. Mm-hmm. If we limit the or right size the request to a very small limit, the application is not able to start.
Yeah, it doesn't start. Yeah.
So for this, Kubernetes comes with a really nice feature. I'm not sure if it was 1.28 or 1.29. Kubernetes introduced a new feature which allows right sizing of requests without restarting the pod, and this is really interesting.
It's 29.
This is 29, but it's alpha. It's alpha. So the problem is the hyperscaler doesn't allow you to use this feature. So we, from Cast AI, waiting that this feature will be better, because then we are able to right-size these requests without restarting a pod. So we can give the application enough CPUs to start, and then if we see, okay, the utilization goes down and down and down, we can tweak these requests to settle it down to free up resources for other workloads on this node.
Are you checking when the application start and you get that highest value for your for the application?
So at the moment, the system is checking the usage over time, and based on this, we will calculate what is the required amount of requests. CPU is elastic, so we are not it's not that much strict there. So for CPU, we are okay if the usage goes sometimes over the requested area. But for memory, this is a no-go for us, because if we are requesting an amount of memory and the application touch this limit, it could happen that the node has no resources available anymore, and you run into the out-of-memory kill. So for this, we say memory per default should have always 10% headroom. In this moment, when the application usage really touch this headroom, we will trigger and right sizing to make sure that we have more memory available to avoid any out of memory kills.
Okay. And how do you, again with the Java application, if you set Java is just always a fun thing to look at. If you set the heap like for Java application to 4 gigs.
Yeah. You cannot shrink down the memory.
No, but is Cast AI then looking in the Java application so you can shrink the heap also?
Not yet.
Okay, because that would be a great addition.
Agree.
So feature request.
Maybe this is coming in the next time.
Maybe the next time we talk to him, we can explain to him. Yeah, we did it.
Yeah.
Okay. So you're reducing costs and looking at what is the time that you look at the application? What time span?
We recommend to let the system run for 7 days to have a valid recommendation there. Our default time is 14 days.
Okay, but what if the application doesn't restart in that 7 days? Then you will have an improper maybe, for example, it's a YAF application. It doesn't restart in that 7 days. Your recommendation is going to be wrong.
So at the end, it's always depending on the workload. So it's also why I say it's make sure that you enable these workload right sizing for application where it really makes sense. And then maybe you have some applications like Spring Boot, Java, where you say maybe it's not the best choice at the moment to do these auto right sizing there, because the problem we discussed, you need this big bunch of resources at the beginning.
Okay, and are you also doing load testing in the application?
No, we don't do this. All our metrics are scraped by the metric server. And we are using these metrics for feeding our system there.
So you've got your application. I can see the metrics over the last 7 days, and I see I have to scale out or scale lower, scale by. That's one part of your application. Do you have more parts of your application?
Yeah. So this what we discussed is just a workload right sizing feature.
Yeah.
It's a pretty new feature we have, and we are working very heavily on new features to extend this product. The other big feature is our cluster autoscaler. So we just want to right size the infrastructure to eliminate the waste there. So for this, Cast AI's infrastructure autoscaler is a replacement for the default Kubernetes cluster autoscaler. And that means instead of having node groups and node pools configured in AKS, EKS, GKE, you configure, we call it node templates in Cast AI, and let Cast AI decide which instance types should be picked up to join the cluster. The philosophy there is keep your cluster as small as possible, bring in the right type of instance at the right time, and then fastly scale out if your application scale out.
So for an AKS cluster, does it create then a node pool for me with nodes, proper nodes, or what?
Yeah, we are not using the auto-scaling methodologies of these of the public cloud providers. So for example, AWS, we're just spinning up EC2 instances which join the cluster. Okay. For Azure, we are creating another object. I cannot remember the name at the moment, but it's following the same idea.
So you're spinning up Linux machines and putting Kubernetes on there?
Yeah, so we are spinning up these Kubernetes default images. So in AWS, you have these EKS default AMIs, or you can bring in your custom AMIs if you want. We are supporting this for each platform. You can bring in your own images, or we are using the default one of the class of the cloud provider, and then spinning up these machines, feeding the machines via Cloud Init with the right data, so that the machine come up, connect to the cluster, join the cluster, and it's in there.
Are you still able to use the cloud managed cluster?
Yes.
Okay, so you can use AKS or an EKS or a GRP, GKE has so much GKE or RST something. Yeah, but still you can use the managed cloud provider service and then put in your own nodes that Cast AI provisions, and put then the right images there. Yeah, that's
Bij ACC ICT staat alles in het teken van continuïteit waarborgen voor bedrijfskritische applicaties. Of het nu gaat over Managed OTAP, Cloud en Kubernetes, ze geven hier invulling aan om door samen met hun klanten een toekomstbestendige strategie uit te stippelen voor het gehele proces van ontwikkelen tot en met productie. How do you calculate the cost of the resources that are being used? Because I've heard there's like open cost and that kind of technologies. Do you follow the same methodologies?
We are, it's our own system. We are not relying on systems like OpenCost. We are having the same idea. At the end, we are checking what is the unit price for a CPU and gigabyte of memory. At the moment, the UI relies on the list prices of the hyperscalers.
Yeah.
We are also there. Next quarter will be a really interesting one. So we have to speak at the next KubeCon.
That's a promise. We will make it work.
Yeah. So next will be Salt Lake City.
I want to go to Salt Lake City.
Yeah.
So
we need to look for some sponsors.
Yeah. We have to speak there. Otherwise, next year in Europe. So there we're coming with a real price engine. This requires an IAM role for your hyperscaler, so that we are able to pull down automatically your saving discount plans, whatever reserved instances.
Okay.
So the system's automatically aware of this and show you the same prices in Cast AI what you see in your cost explorer at the hyperscaler.
Interesting.
Are you doing also carbon footprint?
The
Sustainability part, because nowadays you have to for big companies they have to show their carbon footprint.
At the moment, we don't do this. Yeah,
Feature request.
we'll take a note.
Okay.
So, can you give us an example of a business case where you have implemented Cast AI?
We had a client in Europe, and it's using heavily AWS spot only, and they're running so batch jobs on the system. So the system normally is more idling, and there has an overall count of 100 CPUs maybe, and then they start 3,000 batch jobs. The system scale out to 6,000 CPUs. The jobs were running there for 15 minutes. The system drops down to another amount of so you understand. It's very flappy, spiky, however we call it.
Yeah.
And the prospect was very skeptical that we can save money there because we're already using spot instances. It's a normal story. Say, okay, let's do the POC. Let's check this out. POCs, if we are running them very lightweight, 2 weeks, first week, attach your cluster, let it run for a week so we capture the data and we can see how does your cost for this week is before cast, turn cast on, tweak cast, let it manage the cluster for another week, and then after the second week we have a clear comparison. This is your price before cast, this is your price after cast. And the end result was we are able to save 67% of the cluster cost by Cast AI.
Cool.
For sure, the client has to pay Cast. So after the client paid all the license to Cast AI, the overall saving was 61%. That's easy.
That easy. And the licensing, is that like, do you take a cut from the savings, or is it a license model?
Yeah, we have a license model. So it's split into two different parts. On the one side, you have a base fee. The base fee is depending on how many clusters do you want to manage or attach to Cast AI and what is your overall CPU amount. So we have 3 packages there. That's the base fee. And then on top, we are charging for the optimized CPUs. So for example, you start with 1,000 CPUs, your cluster, Cast AI pushed it down to 400. You will be in charge for these 400.
Okay.
What are the limitations of Cast AI?
So what are the limitations? We do we make sure that the features of Cast AI are equal for all the cloud platforms, but at the end it's also depending on which technology the cloud platform offers us. So we have some features that are just available on Google, because for Google, for example, really what Google is doing really nice is that you have the option to have these custom instances, step away from these default flavors. Say, I'm not happy with the ratio. The default ratio is just CPU to memory 1.4, 1.8, something like this. And if a customer can say, but I have a totally strange application, I need 1 CPU and I need 400 gigabyte of memory. In Google, you can do this. Google can create a custom flavor for you, which exactly these amount of resources. This is also for GKE, for us, a big game changer. We've implemented this feature, but the other providers, for example, doesn't support this. So we cannot build this there. Limitations at the moment, what we said, workload optimization is at the moment limited to vertical autoscaling. Horizontal is coming there.
Yeah.
It works also together with the upstream HPA and Keda. That's fine. So this is one of the limitations, and the other limitation at the moment is the list prices. So customer want to see the real prices. Reserved instances can be already handled. You need to upload the reserved instance inventory to Cast AI. Then Cast AI is aware of this, and this gap will be closed by the real price engine coming in this next quarter.
Yeah.
Then it makes our life very easy on all the sides.
If I use like Google, Amazon, and Microsoft, you can have all my clusters separate, spread out.
Yeah. So this is also very important. If you have any hybrid cloud,
multi-cloud, hybrid
cloud strategy, Cast AI is a fit for this. You don't want to have an individual tool for each of these platforms. It makes no sense. Your tool zoo is exploding, and so multi-cloud is out of the box, multi-tenancy is out of the box there. And for the technical folks, very interesting. Yeah, we have an UI. You don't need to use them. It's fully designed for GitOps. We are shipping Terraform provider. We're shipping cross-plane provider.
Better.
All our stuff is packaged as Helm. I think the most used combination is Terraform and Argo CD on the customer side. So long story short, GitOps. If you don't have it at the moment, you should start right now.
And is Cast.ai running in my cluster, or is it a SaaS?
Cast.ai is a SaaS system. Yeah, we have these two regions, United States and European Union, to be covered with all the GDPR stuff. The data which is captured and shipped is only usage and metadata. No sensitive data are captured. We don't want to have this data. And the agent is open source. You can scan how the agent is collecting data.
If I want to test your software,
very easy. You don't need to speak with sales before. So this is also something what is important for the technical folks. If I remember, as I was as working in ops or something like this, I want to test something out, and then the website tell me, contact sales. I was directly not interested to do this.
Yes,
And you go to Cast.ai. There's a button, log in, create an account. The account is for free. You just need a name and an email address. We don't want credit cards or stuff like this. We are a cool company. Just create an account and then start adding your cluster. There's a connect cluster button. This generates the deployment for you that you can easily adapt this to deploy this agent. And the other cool thing there is in the read-only access is not limited. So you can add as much cluster as you want. You get the cost visibility and you get the recommendation engine for free forever. You pay Cast.ai if you want the automation.
Oh, okay.
Okay,
Well,
that's cool.
That's nice.
So, if I want to know how my applications, the recommendations, how my applications can better work with less resources, I can install and start right away.
I think that's a good way to go to the final question, Jan.
Yeah.
So, the honors is yours now.
I can do it. We always have a final questions. How do you see the future of Kubernetes? And also, I think in conjunction with Cast.ai.
The future of Kubernetes. So Kubernetes is not a new platform, but for a lot of clients, users, it's early stage. People fight at the last years to understand this ecosystem. The ecosystem is massively growing. And also on the other side, if you look on the horizon, there is no real alternative to. So I'm pretty sure Kubernetes will be there for the next 5 years for sure. And what we see at the moment in the market, cost is the most driver at the moment. Everybody is interested to save cost. These nice times are over where all the startups getting millions and millions of dollars. So everybody is interested to save money. And so for this, Cast.ai is the right tool at the right time. So, and then also Kubernetes is a good starting point to save money there. But we should all think about the bigger picture. Start with Kubernetes, optimize your infrastructure, optimize your workloads, and then think about other services as well. Because we all like cloud. Cloud is nice, but cloud is not cheap.
No, cloud is expensive.
Cloud's not cheap.
No, cloud is not cheap. That's a great way to end the podcast. Thank you very much for being here.
Thanks for your time.
Thank you, time. And, see you in the next KubeCon.
See you at the next KubeCon.
Okay, bye.
Bye-bye.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple, Google Podcast en alle andere favoriete podcastproviders.